everyone. Welcome to our webinar today. And I just want people to confirm if they can hear me. You go to the chat section and confirm if you can hear me. And then we can be able to start the webinar. And also you can go ahead and tell me from where you're joining us from. It will be nice to know where people are around the world at this time. So thank you for taking time to join us in this, our webinar. Our webinar today is about helping you to master how to create an ideal IPv6 address plan. We hope that you will find this webinar informative and something to always refer back to in your field. So at the end of the webinar, we would like you to give us feedback of your experience through our platform of engagement and also on our social media pages. We'll also appreciate if you could take time and fill our questionnaire that will be sent to you as soon as this webinar is done. We hope that we will be in a position to send you a recording of this webinar within 24 hours after the webinar has ended, including the slides and every material that you might need. So before we begin, I would like to pass some house rules. So the user interface, all controls are at the bottom of the screen. For any questions related to the webinar, you click the Q&A section. For any other issues, use the comment section and one of our team members will assist you. Remember, as I've said before, to fill in the survey at the end of the webinar, as it helps us continually improve our webinars. As I've said also before, that this session is recorded and we will be sure to send you the recording together with the slides at the end of the webinar. We give and take 24 hours. So in the case you don't receive an email from us with the survey and the presentations that will be done for this webinar, please write to us and we'll be in a position to share this with you. So I'll go straight into introducing our speakers today. Our main speaker is Mr. Bashir Angode. He's one of our trainers at Afrinic in the capacity building department. And James Chirwa, he's the acting member services manager at Afrinic. And then my colleagues assisting us is Willie and Stephen. I am Susan Otieno, and at this juncture, I want to hand you to Mr. Bashir, and we hope that you will enjoy this webinar and learn something from it. Thank you very much. Over to you, Bashir.
Thank you, Susan, for introducing me. And I'd like to welcome everyone to this webinar. I hope everyone is doing fine and your families are okay in these times. Hopefully by the end of this webinar, we're going to learn something and get some ideas. I usually say that it's not about me sharing. We might also learn some other things from each other. You never know. We're talking about how to come up with an address plan. Some of us might have done an address plan before. Maybe you hit some snags. Maybe you did it correctly. You had some challenges. I think it might be best if you also share your experiences and everyone can learn. So today we'll be talking about how to create an ideal IPv6 address plan. And looking at IPv6 address plans, they are very critical to successful IPv6 deployments. If you do not do the proper planning of your IPv6 space, it might mean that you'll end up renumbering in the future or making some changes in the future, which might just disrupt your services. Remember, for us, we had people who deployed IPv6 early on or early adopters. They went through planning, they made mistakes, and I usually believe that we should not be making the same mistakes that they did. So this webinar basically is just a guideline, and we'll look at best practices so that we do not make the same mistakes people have been making, and also to simplify our process in creating IPv6 address plans. So our agenda today we'll be looking at address planning from 3 perspectives. First, how do you estimate your IPv6 needs? So estimating is important because if you don't have IPv6 yet, it means that you'll be knowing the exact block that you'll get from Afrinic. If you already have your own prefix, I believe it's important to re-estimate, especially if you have not started deploying IPv6. It's important to re-estimate your needs and see if the block that you currently have is sufficient. If it's not sufficient, you can take some actions and get a slightly larger block. Then after estimating, we look at how do you get the block. So how, in this step, we call it procure. How do you get your own IPv6 prefix that matches your needs? Then finally, we look at how to implement the address plan in an IPAM. Remember, in IPv6, we don't use spreadsheets. You can use spreadsheets, but it's going to be tough work on you. So it's not similar to IPv4. The address space is so huge. So we recommend that you use an IPAM to implement your IPv6 address plan. So when you're registering for the webinar, I just noticed some interesting challenges. We asked you a question: what challenges do you have or have you faced when it comes to creating an IPv6 address plan? So these are just some which caught my eye and which I believe we'll be looking at also. So we have knowledge about planning, subdividing my IPv6 prefix, the IPAM software to use. We'll talk about that later on. How to deploy. Someone said they want to deploy IPv6 this year, and this is great. This might be a first step in doing that. Someone said everything. So maybe you have challenges in creating an IPv6 address plan. How do you determine the network bits? So that's another comment from someone. Someone also said teaching others how to do it. And I really felt this comment touched me, because if you want to know how to create an address plan so that you can teach others on how to do it, it means that you are working towards sharing the knowledge, not just learning and keeping it for yourself. So I'll move straight to the first thing that you're supposed to look at. And I'll just begin by a short recap of what an IPv6 address is. So an IPv6 address is 128 bits. I believe we might have an idea on that. And the 128 bits are, we have 32 characters, and these characters on my slide, they're represented as H, the H. These characters are called nibbles. So we have 32 nibbles. Each nibble is 4 bits. So it means that if you look at this structure of the IPv6 address, so you'll see that we have a grouping of H's. So we have the first H, 4 H's, the next 4, we have 8 groups. Each group is 16 bits, because remember we've just said that each character is 4 bits, or each nibble is 4 bits. This is important as it will help us when you're looking at how we are subdividing it, or how we are subdividing the IPv6 prefix. So basically H is an hexadecimal digit. And by hexadecimal, we just mean it can be a value from 0 to 9, and then A to F. When you're converting A to F into decimal, that will be 10, 11, 12, up to 15. Then the network prefix at the end, the N, the network prefix, this is the prefix that either you will get from your RIR or from your ISP, and this will also be the prefix that you're going to be subdividing to allocate to various segments or entities in your network. So this is just a recap on what an IPv6 address is. According to our agenda, we'll start by looking at how to estimate your IPv6 needs. Basically, estimating your needs will just be all about determining the appropriate prefix to request from the RIR or from your ISP. If you're doing it from, if you're an enterprise and you're getting your resources from an ISP. Estimation will be based on your network, current network, and will also factor in future growth. So let us begin. The first important thing is do not try to fit your request into RIR minimums. Afrinic by default and other RIRs, RIPE, RIN, and the rest, they have a minimum block that they give you. So it is very common for organizations to underestimate their IPv6 needs, because think of it, you're getting a whole /32 or a /48. And coming from an IPv4 scarcity mentality, this is a lot, right? Well, you can't be sure until you do an estimate first. For most organizations that we've worked with, the default allocation, well, might be enough. But we've seen scenarios where there is a need for a larger block than what was issued by default. Another scenario can also be if you got your block several years ago and you have not deployed. There might be many reasons that people are not deploying IPv6. Things happen. And maybe you've seen IPv6 excuses, right? There are some hilarious excuses on why someone has not deployed. People have not deployed IPv6. You can check on Twitter. There's a handle called IPv6 excuses. They're very hilarious. So maybe you've not deployed IPv6. So if you had made your request 5 years ago and you want to start deploying now, it means that things might have changed within that 5 year period. And it might mean that what was sufficient 5 years ago may not be sufficient now. So you need to re-estimate and get the appropriate block. And that is what we're going to do first. So to get your, or to calculate your space needs, we need 3 things to be done. First thing that you need to do is determine the total number of bits that are needed based on your network hierarchy, right? So you have your network diagram, you know your network hierarchy, you're going to determine for each level of your hierarchy, how many bits do I need? And we're going to look at an example in a short while. Then, of course, you'll need your network diagram. And for us to do this, we're going to avoid complex mathematics. Today, we're not going to be thinking a lot and doing complex maths. We're just going to be using a lookup table to help us to determine this. Then you also need to get the number of bits. After getting the number of bits needed for each of the level of your hierarchy, you also need to decide on the network end prefix or the end network prefix. So the number of bits, in this case, we've denoted them by W, X, and Y. And then you need to choose or decide on a prefix that you're going to allocate to your customer. This is normally a design decision, and it will depend on customer profiles. And based on these customer profiles, you're going to allocate a specific prefix. So for example, you might decide to give enterprise customers a /48 or home and broadband customers a /56. So this is all a design decision. We'll look at best practices on which prefixes to select for your end networks later on. Then with this information, you have the number of bits, you have the end network prefix, you're going to be able to calculate the size to request from your RIR. So basically, you'll just be subtracting the number of bits that you've gotten or that you've identified that will fit the number of entities in your hierarchy, and then subtract that from the end network prefix. And you're going to get the prefix that you're going to request from your RIR. So let's look at some sample hierarchies as we build up to the first point, determining the number of bits by using your hierarchy. So in this scenario, we have an ISP, which has presence in various regions. And then in each region, for the largest region, we have a number of sites. And then the largest site has a number of customers. A site in this case can be your points of presence. So this is how a sample prefix will look like. So we've looked at the hierarchy. So this is how a sample prefix will look like. So you can see that our mapping of the regions, we have the regions and we'll have the specific number of bits to satisfy the number of regions that we have and also factoring future growth. Then we also have a certain number of bits that will identify, that will satisfy the sites that we have per region. And then we also have a certain number of bits that will enable us to meet the requirements of our number of customers per site. The end customer or the end prefix size will be predetermined, like I mentioned earlier. So this is what you'll be giving to your customer. This will be predetermined. So let's look at another example. If you're in university, so this is how your hierarchy might look like. So instead of regions, this time around we have campuses. And then in the campuses, we have buildings. In the buildings, we have departments, which are the end networks. The departments can be your VLANs. Then the sample prefix will look like this. So you have the campuses. Based on the number of campuses, you'll have a certain number of bits. Based on the number of buildings per the largest campus. So we'll always be looking at the largest and the rest will automatically fit in. So the number of buildings in the campus and the number of departments. The department prefix size will be predetermined. Then finally, in an enterprise network, same to what we've been looking at, but this time around we have headquarters as the first level, the branches, various branches. And then in each of these branches, we have various services and the end networks, or in this case, we have the department sales, marketing, which can be our VLANs. Then this is how the sample prefix for the enterprise network we've just looked at will look like. So we have the branch, certain number of bits will be reserved or will be used to come up with prefixes for the branches. And then inside the branches, we'll have a number of bits allocated for the type of service. And then inside the type, we have the departments. So going back to our steps. So we said your hierarchy will be used as an input to get the number of bits that are required for each level of your hierarchy. And this will be dependent on the number of entities. And then we have looked at sample hierarchies, which will guide us to determine the number of bits needed. And we're going to simplify the identification of the number of bits by using a lookup table. So let's go ahead and see how we can do that. And in this step, I think we've mentioned it several times now, you'll need your hierarchy. So this is a lookup table. We'll use this table based on the number of entities at each level of your hierarchy. So remember we talked of the first hierarchy for the ISP. The ISP might have presence in various regions. So regions is an entity or is a level. And then the entities there, the number of regions will determine the number of bits that we need from this table, right? So for example, if my ISP is located in 5 regions right now, and we like to have presence in 10 regions, maybe in 10 years' time. Tell me in the chat section, how many bits do we need to satisfy that? Someone says 16. 12, 4. So the answer is 4 bits, right? So the first person to, yeah. So we have 4 bits that will enable me to meet the requirement of 10 regions. So I need 4 bits. So if you look at the first column, so I need 4 bits to achieve that. And you can use any, so essentially we're just trying to avoid doing, but there's a calculation behind this, right? So we're trying to avoid all that and simplify the identification of the number of bits per each or for the number of entities that are there. So if you say, let's say, for example, if I have 700,000 customers, so how many bits will I need to satisfy that number of customers and even have room for growth? And you can see, yeah, right, 20. So 20 bits. So if you look at, remember I've said 700,000. You can't use 16 because 16 only allows us to have 65,536. So we need to go to the next boundary, which is 20 bits. So not 16 bits, but 20 bits. Yeah, so most of us got that correct. So let's go back and see how to do that. We've looked at how to determine the number of bits. Someone says he thought I said 7K, 700,000, sorry. Yeah, sorry. For any questions, use the Q&A section. So we've looked at how to identify the number of bits. And just to mention, we look at a worked example in a short while with the real scenario. So we've looked at how to find the number of bits. Next, we said is how do you determine the end network prefix? And this will be a design decision. So here's an example of some prefixes that you might get. So we have /64, /60, /56, 52, 48. So remember in IPv6, we always talk about subnets, not the number of hosts per subnet. So it's something that we have to get used to. We don't normally worry about the number of hosts in a subnet because essentially we'll have a lot of hosts in a subnet. Reason being, in IPv6, it is recommended that your end network or your VLAN should be configured as a /64. So this means that you are left with 64 bits that will identify or that will be used as an interface identifier. And 64 bits gives you 2 to the power of 64. That's quite a lot of addresses. And you can see why we don't worry about the number of hosts per subnet. If you're an ISP, don't give your customers a /64. Why? Because this means that they cannot break it down further or subnet the prefix in order to support additional VLANs in their networks. What we recommend is, if you're being very, very stingy, the minimum you should give is a /60. /60. So a /60 basically, remember I said the end network prefix is /64, right? So it gives you it gives the customer 4 bits to work around with. So it means that 4 bits can give you how many networks? 2 to the power of 4, which equals to 16. So the customer has a possibility of coming up with up to 16 subnets. So don't give your customer a /64. Always give out a /60, or some ISPs will issue a /56 to customers. We also recommend that the largest prefix to be given to large enterprises or corporate customers should be a /48. Anything larger than /48, it means that the enterprise is eligible to come directly to Afrinic or any other RIR to get their own resources. So for enterprises or corporate customers, give them a /48. So we have the prefixes and network prefix, and we'll come back to the prefixes later on we'll look at some exceptions. We've said that /64 is the N network, recommended N network prefix, but there are some exceptions, slight exceptions. So how do you calculate the required prefix size? So we already have Z, which is a design decision. We've looked at how to get W. I'll just show the table again and you'll be able to remember. Then we've seen how to get the number of sites and the bits that will accommodate the number of regions. So basically, what we have here should be dependent on your network. So the W, X, and Y is dependent on your network hierarchy. And this will enable you to get the size to request from Afrinic. So something else that we recommend is sticking to Nibble boundaries. If you remember the first slide, we talked of the prefix, the IPv6 prefix, having 32 nibbles. So if you remember, we talked of the H. So we have 8 groups of this. So each of the nibble is called an hextet or an hexadecimal character, which is 4 bits each. So it is important to stick to Nibble boundaries. Why? Nibble boundaries mean that you're working with increments of 4 bits. So this single H, you'll be incrementing by 8. And it enables your address plan to be easily readable and have, I can call it consistent increments, right? So if you look at an address that follows the Nibble boundary, you're going to notice that the address is sequential. So you're going to have the first address as, let's say 1, 0, 1, 2, 3, up to F, because you're just working on this boundary over there, right? The Nibble boundary is also important because, so it's also important because the way reverse DNS works, or how we map reverse DNS when you're creating the PTR records. In IPv4, this works with the 8-bit boundary, right? Or the byte boundary. And in IPv6, reverse DNS works on the Nibble boundary. So for example, if you have a prefix 2001 db8 : /29, it means that you can't have a PTR record for this block. You need to have 8 reverse zones for the sub-blocks. So you're going to have 8, the first one, I'll just list the first one, 8BD01002.ip6.arpa. Next one will be 9BD So you need to have all the 4 subprefixes as PTR entries. So you can see why you need to stick to Nibble boundaries, which simplifies a lot of things and makes it easy for you to work with the IPv6 address. And also it's easy to identify the address by just looking at it. You can be able to know the various blocks since they're consecutive. I know with Nibble boundaries, you might be thinking that, of course, we'll be wasting some blocks, right? Because you're moving from, if you have a /32, it means that you'll be incrementing by 4 bits, /32, 36, You move on to 40, 44, 48, 52. So you're always incrementing by 4 bits. It means that your hierarchy is very easy to identify when you work with the Nibble boundaries. But you might be wasting some space or some blocks as you're doing that. But don't worry, currently we're using a /3. A /3 gives us a possibility of having up to approximately 35 trillion /48s, right? If you look at the world population, estimated world population in 2050, we expect to have 9.3 billion people in the world. So essentially, the current block means that we have 3,500 times the number of population people that will be there in 2050. It means that you can give everyone 3,500 /48s and still be left with some spare change. So don't worry about space. We have a lot of space in IPv6. So let's look at an example. We looked at how to determine the hierarchy. We looked at how to determine the N network prefix needs, right? So let's use this example to look at a worked scenario, right? So an ISP has operations in 10 cities. The largest city has 50 POPs, the largest of which has about 2,700 clients. How much space should it request from Afrinic if it plans to give each of its customers a /48? So we're going to do it systematically. The first thing that we need to do is we've identified the entities, and we know the number requirements. So we have the entities, cities, sites, and we know the N network size. We also know the number required at each of the level of our hierarchy. We need 10 cities, and then each city, the largest city, remember we'll be talking of the largest city. And then the largest city has 50 sites. Then the largest site has 2,700 clients, and we have our N network prefix. So using this information, what is the required prefix size to request from Afrinic? So let's go ahead and see how we can do that. So basically, you need to identify for the cities, how many bits do we need so that we can cover our 10 cities? And then use the lookup table at the bottom. So based on the count, how many bits do we need? Or how many bits will satisfy the number that we got, right? So for the cities, you'll see that we need 4 bits, right? Since you have 10. For the sites, we need 50, we need 8 bits. For the clients per site, we need 12 bits. And I can see some people already sharing the answers on the chat, right? The first ones. Yeah, and that's very good. But working through it logical, right? So we need 4 bits for the cities, which gives us an option of even having up to 16 cities. So there's room for growth. And then for the sites, we need 8 bits. Then for the clients per site, we need how many bits? 12 bits. The N network prefix, or the prefix to request from Afrinic, will just be this, the 4 plus 8 plus 12 minus our N network prefix, or what we'll be allocating to each of these customers, right? So if you add this up, it gives you 24. 48 minus 24 gives you /24. So you need to request a /24 from Afrinic. And you can see how simple it is. No stress of doing some calculations and yeah, working with large numbers. Everything is in here. So let's look at, we've seen the number of bits required, right? So we need 12 bits, 4 bits for the cities, 8 bits for the sites, and 12 bits for the clients per site. Remember, again, we're working with the largest, right? So if you look at the hierarchy, remember it's the ISP. So we said that each customer needs to get a /48, right? And we said in this site, this was our largest site. Our largest site had 2,700 customers. And you can, this image shows you why we're just looking at the largest site, right? So a common mistake, sometimes you'll find that when you're doing the estimates, you'll put all your customers in one. No, in IPv6, we want to do hierarchical addressing. So you'll just be working with the largest of your entities, and the rest of your entities will be sorted out. So for example, we have a site here, site 2. So site 2, as long as we can determine the largest site and the number of customers that are there in the largest site, which is 2,700, it means that the others will be covered automatically. So for us to satisfy we said that the end customers, each of these customers from 1 up to 2,700, they need to get a /48, right? So what prefix are we going to need at the site level? So what is the prefix? Do we need a /32? Do we need a slash? So in the chat section, if we can, I want to see the first person to get it. So at the site level, what is the prefix that we need? Someone says 32, then always go back to the number of bits, right? The number of bits in our hierarchy when you're using the lookup table to calculate. I can just go back so that you can see. I think this will be better. So we've said the clients per site. We said the largest site has 2,700 clients, and we need 12 bits to satisfy that. So if you go back to our hierarchy, it means that you need a /36, right? So a /36 enables you to get up to 2,700 /48 and even more /48, right? So what about the city level? And you can look on your left, actually, we have the number of bits. So over here. So at the city level, we need 4 bits. So it means that we're moving, and the best way to look at it is we started from, we need 12 bits for us to give each customer a /48. And then we needed how many bits? 8 bits for us to have up to 50 sites. So it means that our prefix size will be a /28. So essentially that will be 36 minus 8, giving us a /28. And then remember we said we are present in how many cities? 10 cities, factoring the growth. So 10 cities, we subtract, we got the number of bits to be 4. So the prefix that we're going to get is a /24. So if you're working, because we did it from the other way around, right? So you have your block /24. /24, you need to split it into your 10 cities. To do that, you need 4 bits. So you're going to need the resulting prefix will be a /28, right? And then in the cities, we have sites. So to accommodate the sites, because we said the largest city had 50 sites. So we needed 8 bits to do that. So per site, the prefix length is going to be a /36. Each site is going to get a /36. Then in each site, for you to allocate a customer a prefix, so we need 12 bits so that we can be able to have each of the customers can have a /48. So I hope that is clear, right? So you get the number of bits, you have your hierarchy, and then based on your hierarchy, you will determine the number of entities at each level of your hierarchy. Is it regions? Is it cities? Then is it POPs per city? Something like that. And then you also determine what prefix are you giving to the end network. We have a tool that we created in Excel. I'll just show you quickly, and I'll share it with you. You just enter the values and you're good. So let me just show you. Yeah, so we call it the hierarchical address planner. Yeah, so it's even, I think I filled it early on. So in this Excel spreadsheet, we have all the formulas. I hope you can see it. Yeah, so we have the formulas. You'll type in the end network prefix, what you desire to give to your customers, and then you enter the various entities, cities, sites, customers, and it will be changing. If I decide to change this to, let's say 5,000, so the number of bits will modify automatically. So I'll also share this later on, and it will help you to, it's basically the lookup table, but this time around, you just enter your figures and the calculation will be done for you. So I'll share this with you later on. So let me see. Yeah, so at this point, I'd like to invite my colleague, James. James is from the Member Services Department. If you have any interesting question that you need to ask from the Member Services team, so he's the guy to ask. And James will just show us, we've looked at how to estimate, right? So at this point, you are calculating your needs. By now, you've seen that you need, in our example, we've seen that we need a /24, right? So once you've estimated your needs, you need to get the IPv6 address from somewhere. So James is going to show us how to get the resources, how you can actually go ahead and apply for the resources on MyAfrinic, and he'll also tell us 1 or 2 things about the process and any interesting thing that he'd like to share. So James.
Hi, Bashir.
Hi. So the floor is yours.
All right, thank you. Good day to you all. As my colleague has introduced, I'll just give you a simple demonstration on how you can easily get the IP resources. Oh, Bashir, can I have the screen, please?
Okay, go ahead.
So once you've done your estimation based on what Bashir has explained so far, the next step is now you come to us and request for the amount that you have so far estimated. First of all, what you need to also understand is the type or the nature of your network. Are you a service provider or you just an end-site user whereby the IPs are only going to be used on your own network? Understanding that helps you that once you come to us, you request for the right type of resources. So you can either come to us as a new member or you can come to us as an existing member who already maybe has IPv4, or you could be having only an ASN with us. You can come, you want to request for IPv6. If you are just coming to us as a new member, this is the page you're seeing. That's where you can come and request for membership with Afrinic. Then you can request the type of resources that you want. That would be IPv4, IPv6, and ASN. So this is the platform for the new members. But now for the existing members, this is where you get to. I'm pretty sure most of us on this webinar are familiar with this interface. So you should be able to at least have an idea. First of all, to be able to access the platform itself, you need to have what we call the NIC handle. This is a personal unique identifier. It is attached to your organization and it enables you to do certain particular activities within the profile of your organization. So I'll just take you through a simple demonstration of how you can be able to request the IPv6 resources. But first of all, let's understand when you go in here, once you log in, you'd go to the IP resources tab, whereby you'd be able now to go under the IPv6 section. On that IPv6 section, okay. So on the IPv6 section, as you can see, you come here under the resources and you move to IPv6 section. You realize that there are two sections that you are being shown here. There's the first one that says allocations and the second one that states end user assignments. There's a difference between these two types. For members that are basically end site, that means that all you need the resources for is to use on your own network to serve a certain specific purpose. For example, a university which wants to run their own network, or maybe a corporate enterprise that is involved in some other business. They want to enable maybe their network and also be able to maybe provide some of their internal services. They would be able to, or they categorized as the end user group. And then we have these, the service provider group. Those are the ones that would come and get the allocations. Service provider include those who do the, who would be ISPs, cloud service providers, hosting providers, that kind of category whereby once we give them the IP resources, they take the IP resources and further give them to their customers for the service they are providing. So that's an intrinsic difference between the two. I'll just quickly show one decision-making chart that you can use. Are you able to see it?
No.
No, okay.
You can just, okay.
Yeah, let me just share it. So this is one basic decision-making flow that we can you can use instead of determining what type of resources you'd need. So, do you need an let's put it now in this case IPv6 block for your own network? If the answer is yes, then obviously you need an IPv6 PI block. If no, then the other question is, are you going to, or will the block be used to do BGP with multiple ISPs? If yes, then that means we need to ask a further question. But if it is no, if you want to do BGP with multiple peers, BGP peers, you won't be able to use an IPv6 PA, which is a provider aggregator. What it means is another service provider, an upstream, shares it with you, gives you a part of their block, and using that particular block, you can only use it through their connection. Most network providers, other upstream providers would not accept you to take that particular block. So if you want your own independent IP, that is it. And with that particular independent IP block, would you want to announce the same prefix from different sites? If yes, then what you need is a PI, which is provider independent. So provider independent is what we give to an end site who wants to be able to do BGP with at least one or even one or more than one upstreams. And at the same time, they could be also able to announce that particular block from multiple sites. In case you only need to connect to a single upstream, and you also only have one site, you don't have multiple sites, then you can get a block from your upstream provider. They would give you part of their block, which is what we call a PA block, provider aggregatable. The ISP would take their block and give it to multiple smaller customers of theirs. But at the end of the day, they will aggregate it and announce it publicly to the internet as a single block. That's most of the most common use case. So as an end site, at sometimes you may not need to have your own PI. Then you can get a block as part of a service provider's network, which as a service provider's block, which is called the provider aggregatable. With that, you need to know that you can't take it to another service provider. They would not allow you. At the same time, you cannot originate it from multiple sites. You only have to use it through that particular upstream of yours. But if you happen to get your IPv6 PI from Afrinic, that would enable you to be able to do BGP with multiple peers. And at the same time, you also have the flexibility to announce that from multiple sites, either with the same upstream or with multiple upstreams. So once you've made your decisions on the type of network after the estimates and you've learned how your network is, that's when you come to us, you choose appropriately here. Request either an IPv6 resource or you choose an IPv6 new assignment. So if you're an end user, an assignment is what qualifies as the PA. While for service providers, an IPv6 allocation is what would be suitable. You would be able to tell now after you've studied your network, after you've done the estimate of your network, in the same way, you also understand how your network is, and then you would know whether you fit in as an end site or you fit in as a service provider. And what you need is either a PI, which is a provider independent. You are independent of any service provider, so you can take it to any other service provider and they would be able to route to take your prefix up to transit. You'll be able to get transit through any service provider. But with the PA, which is provider aggregatable, if one service provider gives you a part of this, then you don't be able to go with it through them. So understanding your network, once you come into our portal here, you would know which particular IP type of IPv6 you need. So if you are an end site, you come here and request for the new assignment. If you are a service provider, you'd come here. So I'll just demonstrate simply what you see once you get there. If you want to request for an allocation, you are a service provider, then all you need to do is get to this interface. You choose based on your planning that you've done or that estimate, what it has shown you. This is where you come. Like my colleague said, the minimum you can get of an allocation as a service provider is such 32, but don't tie yourself to the minimum. Do a proper estimate, do a proper IP plan, put Nibble boundaries into consideration. Once you've done that, you fill in the rest. Net name is just a description of what you want your network to be called according to our WHOIS database. So you now service offered, you describe the type of services that you're offering. If you have any existing allocations regarding IPv6, you also indicate it. IP addressing plan, that's most important. So if you want a minimum, normally we ask for the IPv6 plan, but most of the times if you already have an IPv4 network or you've given us an IPv4 network and you're coming for the minimum, either a /32 for service provider or for LIRs, which are getting the PA, or /48 for end sites, we look at your plan, but it can be accepted even without a plan if you have given us an IPv4 plan. But if you want more, you've done your proper estimate and you want more than the minimum, then you need to provide that particular IP plan here, or else you can just attach, if you are working on it on a spreadsheet or any type of document, you can browse or you can attach the document. Most of the details here are the descriptions. If you want, you can provide. These are not mandatory, but if you have a properly detailed, or it could be a high level or well-detailed plan of your network, you can also provide, because it also helps us understand your needs much better. And even justification, normally when you are getting more than the minimum, you need to give us more information. So basically, these are the simple information that we need, but my colleague stressed more on the Nibble. Our team, once we get your request, we analyze your planning, and at times where we see necessary, we also advise you that we recommend that we push you to a Nibble boundary for the better, for all the advantages that we have said earlier on. So once you fill this, you just move on and do a request for the allocation. Once you get it gets to us, we look at it, we do the assessment of your plan, then we let you know. Normally, like I said, if you already have IPs with us, IPv4, IPv6 is given at no cost. So you'll not be charged for the IPv6. It will be given at no cost. But if you are not having any, and assuming you are becoming a new member through this interface, and all you want is IPv6, or also you could be a member with us only having an autonomous system number, and you need IPv6, after you've done this process, we've evaluated your needs and we are ready to go. If you don't have IPv4, you'll be invoiced, you'll be charged. There's a cost attached to IPv6 for members who don't have IPv4. But for those that have IPv4, when you are getting IPv6, there is no cost attached. So once, for those that have IPv4, once we finish this process, we proceed and issue the appropriate IPv6 prefix that you requested for. And for those that don't have IPv4, then once you make payment to us, that's when we'll give you the appropriate IPv6 block. At this moment, I think that's all I had for you. My colleague Bashir will proceed.
Okay,
Bashir.
thank you, James, because we've seen it when we deal with people, when you're helping people to deploy IPv6.
Yes.
So when you ask, there's usually a misconception that you're going to be paying more, especially like you mentioned, if you have IPv4.
Yes.
So what I like to mention is if you already have IPv4, you're eligible to get an IPv6 prefix at no extra cost, right, James?
Yes, exactly. So
Yeah,
the whole point is, if you just go to our billing schedule, you would see that there is cost per each type of resource attached. But then there is further information provided on that chart, which describes further the different scenarios that are there. So it speaks, but maybe most of the times people just go on the tables and just see the amount to say, oh, this is the charge for IPv6, but they don't get to take the time. And this is why I can encourage people, read through the whole billing schedule. or even some of our policies. This particular no cost for IPv6 for those who have IPv4, it's actually a policy condition or a policy text. So if you go and read the IPv6 allocation policy in Afrinic region, it clearly states that. So you should be able to understand, but also I encourage people to read the billing schedule better so that they will be able to know that, oh, if I get IPv4, if I have IPv4, then that particular IPv6 charge is waived.
Okay.
Yes.
Thank you very much, James.
Right.
Can you stop sharing your screen? Okay, thank you. So we've seen how to get the resources, how to estimate, and how do you get the resources. Next thing that we're going to look at is how do you implement. We've seen how to estimate, how to procure. So how do you implement an address plan with your own space? We'll use the example that we had worked with earlier on. So whereby we have our ISP, the ISP is located in various regions or cities. And then in each city, we have various sites, and the largest site had 2,700 customers. And then we saw that for the customers, we predetermined that we need to give them a /48. That's a design decision. Then for us to give each customer /48, we need to have /36s at each site. And then the same thing with the regions or the cities, /28, and our block is a /24. Before we implement it, let's look at some best current practices. So typically, like I mentioned earlier on, for any multi-host LAN subnet, you'll be configuring a /64 or allocating a /64, allocating and configuring a /64. So the reason we do this is you need to do a /64 because if you don't use a /64, let's say if you use a /65 or /70, 80, it means that you'll be interfering with how interface identifiers are generated. We have two mechanisms, the Slack, which is used to give out addresses, and also DHCPv6. But the interface identifier, which is the last 64 bits, there's a way that is generated. If you go past the /64, you're going to interfere with that and things will break. Also, auto configuration, like I've just mentioned, Slack depends on a /64 prefix to fill in the /64 interface identifier. So if I was to just display it for us to understand. So if this is your prefix, so this is 16 bits, then up to here, this is 48. Then let's say if you have, so this is your /64. So the rest of the last portion, the last 64 bits are usually reserved for the interface identifier. So you should always stick to /64 as your end network prefix. Also, infrastructure-wise, we recommend that you reserve the first subnet in your address plan. And this is where you'll be getting your loopback addresses, point-to-point links, and also server addresses. I'll show you an example in a short while. For loopback addresses, it is, we recommend that you reserve a /64, then pick a loopback from that /64. For point-to-point links, we recommend that you reserve an individual /64 for each of your point-to-point links. So for example, if you have 20 point-to-point links, you're going to have 20 /64s. But in terms of configuration, here's how you're going to do it. So when you talk of point-to-point links, so we said you plan an allocator /64, but configure, you can configure /64, 124, 126, /127. So we recommend configuring a /127. Why? And I'll also mention why you might also go back to doing /64s. But basically /127 is just for security reasons. Remember, you're configuring two addresses at this end over here and at this end. So it means that you're left with 2 to the power of 64 minus 3 addresses that you can configure on this point-to-point link, right? So there's a security attack called the neighbor cache exhaustion attack, whereby someone can send packets to this link, packets from this prefix, this /64 that are not yet configured, right? So an attacker can send packets to the router. What the router will do, it will try to send out a neighbor solicitation to do resolution, layer 2 resolution. Remember, these prefixes don't exist. So it will put the entry in the cache, then send out a neighbor solicitation and start waiting for a neighbor advertisement after a specific period of time. So imagine if this is done for all the packets sent to 2 to the power of 64 addresses, 2 to the power of 64 minus 3, it will end up exhausting the neighbor cache. So that is why it was recommended to configure /127. Basically, you're just reducing the attack surface. Remember, it's not for the purpose of conserving addresses. Because come to think of it this way. If I configure 2 addresses on this point-to-point link, and if I configure 1 million addresses, what's the difference? Get the point, right? So it's not all about conserving. The fraction of addresses we're going to use is going to be very minimal. So it's not about conserving addresses. So that's one of the reasons why you'll do a /127, just for security purposes. But I can mention that also some vendors started to implement other mechanisms that prevent these types of attacks. So for example, Cisco has a feature called Destination Guard, which means that it checks, the device will be checking the packets received to see that if the addresses in those packets are actually configured. If they're not configured addresses, the device will just discard the packet. /126, the reason you might want to configure /126, what we've encountered is some devices don't support configuration with /127. Yeah, so you might end up configuring a /126 or /124. But basically the thinking was that you're reducing the attack surface when it comes to these types of attacks. If you're sure that your device has all the necessary security mechanisms, nowadays you can also do rate limiting of neighbor solicitation packets. You can do a /64, but I will recommend a /127, which is the safest method is the guaranteed method. You'll never have any form of attacks with this neighbor exhaustion cache attacks with the /127. So that's the point-to-point links. So when it comes to assigning sub-prefixes, so you have your block and you're splitting it up. So there are 2 ways you can assign the sub-prefixes, or you can split your blocks and assign them. So you can use sequential, whereby you'll pick the first subnet, go to the second subnet, go to the third, the fourth, sequentially, right? But when you talk of bisection, so bisection, you'll be skipping. So you don't do it sequentially. So instead of going from allocating the second subnet, I'm going to skip to the 6th subnet. I'm going to skip to the 9th subnet, come back to the 4th. So what this does, if you compare the 2 allocation methods, sequential and bisection, sequential on the left of your screen and bisection. In sequential, picture this, if I allocate the first, a customer comes to me and I allocate the first block, the first subnet. So it means that I've already allocated the next one. If they want additional space, it means that there's no room for growth in with this, right? So no room for growth. But with bisection, if I give customer one the first block, I already have some extra space over here. So if customer one comes later and says that, oh, I need more, so I'm just going to assign them this, allocate them the second one, and aggregation for them is going to be very easy. It will be all about just changing the prefix size. You don't have to reconfigure anything. And the same thing applies to the fourth subnet and also the sixth subnet. So if someone wants more, there's always space for additional resources. So let's look at a worked example as the final thing. So I'm just going to show you how to implement an address plan in an IPAM. And before I do it in an IPAM, we'll use the scenario that we looked at earlier on. We determine the number of bits at each level of our hierarchy, 4 bits for the cities, 8 for the sites per city, and 12 for the clients per site. And then we know that we need a /24. So we'll assume that this is the prefix we've been given, 20010D. So in red, this is our /24. It means that we can't change this. So if you remember, we talked of 4 bits for the hexadecimal characters. So this is 4 bits. So this group is going to be 16 bits. So we have 16, and then we have 4 plus 4, giving us 24. So it means that we'll be only working with the black zeros, the characters in black. Going back to our hierarchy, since it's important to always clarify. So again, I think we've looked at this quite a number of times. So customers /48, then /36, and /24 is what we got. So I'm going to show a demonstration using PHP IPAM. There are many IPAM solutions that you can use. We have just UIP, we have quite a number of IPAM solutions. In our case, I'll just demonstrate how to implement our address plan on PHP IPAM. The reason I'm using this, it's open source, it's free. And also, if you're interested, I'll share the image for this and you can install it in your own network. But there are many, if you already have your in-house IPAM, you can go ahead and use it. So I'll you'll try this at your own time, but we'll share an image which you can install. Yeah, so from the IPAM, we need to come up with we need to implement our block, our IPv6 block in the IPAM. So I'll just come here to subnets, then IPv6. Because this is a demo version, so we already have some things in here, so we'll just ignore that. Let me go ahead and create a new subnet with our sample prefix. So our subnet is 20010D /24. Then the description, I'll just say company. And then I also want to show as name, and I'll show you why it's important. So let me just change this to ISP. I'll go ahead and add the subnet. So it's saying, so I have a block over here. So if you click on it, you can see the reason why I showed as name for this specific IPAM. So it's being displayed over here. So just ignore the rest since this is it's a demo version. So what I'll do next is edit the subnet properties, and I'll come down to resize/split. Resize/split. And I'm going to split this subnet into /28. Remember, this was the level for the cities. And I can even say cities as a description, then split subnet. So you can see on your left, we have the subnets listed, /28, right? So what we said is we have the various /28s. The first thing that we said is reserve the first block for your infrastructure. So I'll just rename this to infra. So we have infra. And then remember we said currently we are present in 5 cities. So I'll just do one example, then because it maps to, it's the same thing for the rest. So I'll leave some blocks, free blocks, then come to this and edit it and say this is city 1. And then from this city, we want to split it. Remember we said that for each city or region, we have various sites, right? So we want to split this into /36s. So I'll just come down to resize/split. We want to split this into /36s, and we'll have up to 256 /36s. So I'll say these are, because the end product will be prefixes for sites, then split subnet. So now you can see our hierarchy, right? So this is the first city. And then in this city, we have, actually I should have renamed this too, so that it's clear. But you can put any, it will now depend, once you're doing it with your own address plan, you'll be putting in the right entries in here. So in this city, /28, we have various /36s. The next level of our hierarchy was to go to customers. So we said that we need /48 in this city. So in this city, we have various sites. And then each site should be able to accommodate 2,700/48. So I'll just come and skip, maybe use the 4th one. So we'll say this is city 1. Site, this is the site level now. We're talking of the site level. And then for this block, I'm going to split it. We want to split it into /48, right? But for this specific IPAM, you can't have large increments. You can only increment by 8. So from 36 to 44 or 32 to 40 by 8 only. So I have two options. I can split the block for the sites into /44s. I'll have 256 /44s. And then this /44s, I can now be getting my /48s. So from each /44, I'm going to be getting 16 /48s. But I think the best alternative is to split this block first into 40s, so that we can have in each of the subdivided block, we'll have many possibilities for the customers. So I'll split it into /40s. So I'll say customer. So this is site 1, customer subblock 1, and then I'll split. So now we have various /40s. Remember, we're still at the site. Then from the /40, I can now come and split the /40 into /48s. And then I'll say this is, so this is at the customer level. So we're going to have up to 256 /48s per /40. So I'll have customer 1, 2, 3, up to 256. So this is how you will do it in an IPAM with your hierarchy. So of course you can do the same thing, and you can see how, if you look on the left, it looks very, if you name it according to your own various regions that you have, it's very easy to identify and easy to work with. So coming back to the infra, we talked about, maybe as the final thing, so we talked about point-to-points, loopbacks, server addresses. So an option will be, I can split this /28, because you have very many possibilities with this block. So I can split it into /32s, so we have various /32s. I can pick one of the /32s and say this will be for, let's say, and I know this can be quite a lot, yeah? So you can decide, instead of going to /32s, you can go to /36 or /40s, and then you have all your blocks in there. But I'm just going to show what you might get. So you'll have your block reserved for loopbacks. I'll have a block reserved for point-to-point links. So you just rename it. Then the last one, I can call this servers. So we'll have something similar to this. But of course, like I mentioned, this is just an example. It will depend with your network hierarchy, and based on your network hierarchy, based on the prefix you've received, you can now be able to identify the right size or block to reserve for your infrastructure. So loopbacks, what you're going to do is, since you'll only be needing one subnet, instead of splitting, maybe this is the only difference that you'll be doing. instead of splitting, you're just going to be adding a new nested subnet, especially if you're working with this PHP IPAM. Because think of it, if you have a /40 or /36, splitting it into /64s, you're going to get a lot of addresses. Same thing with the point-to-point addresses. So what you'll do is you just add the nested subnets and add a specific /64 or any block that you want to add. So in this case, I'll just choose, because it's quite a number. So I'll go down to the /64s and add a nested subnet. So I can pick the one, and then I can give the subnet description. Then add. So this prevents you from having a lot of blocks which are not going to be, which you don't even use. So you just be adding specific blocks that you currently use, and it's easy to manage in the IPAM. The same thing with the point-to-point links. You're going to split your prefix into, so instead of adding a nested subnet or splitting the subnet, you're going to add a nested subnet. So this is the only maybe key thing that's worth mentioning for this IPAM. First thing we saw is you can't break your block past the 8-bit boundary. So you need to do 8 bits, 32 to 40 or 32 to 36, and then 4 bits. So you can't do 32 to, let's say, 48 or 36 to 48. So of course, like I mentioned earlier on, the IPAMs we have quite a number of IPAMs. So it's all about, don't do this in Excel. So use an IPAM to document your IPv6 address plan. If you want us to help us, I'll share the image file for this IPAM, and you can install it in your own infrastructure and document your own your IPv6 prefix. Some IPAM solutions will give you the DDI, so provide DHCP, DNS, and the IPAM in itself. For this specific one, I think you can only integrate it with the Power DNS, the last time I checked. So you can't use it with Bind or any other DNS platform. So I'll share the link to this, and you can download it and set it up. And if you need help, we can always meet and we'll assist you in setting it up. So the final thing that we'll look at before we wrap the webinar is considerations for virtualization. I believe nowadays, if you compare traditional servers and virtualized servers, traditional servers, you'll have the physical server, which most likely was connected to a single VLAN. But for virtualized servers, you have to factor in several data VLANs. And it means that you need to plan for a /64 for each of your data VLANs, especially when you're talking of servers. So if your server has various VMs in it, so you might end up giving or allocating your server a larger block than a /64, so that the VMs in the server you can now be allocating the relevant prefix length, the /64s. And then I think we've mentioned this. It's called the IPv4, the mentality, the conservation scarcity mentality that we have in IPv4, whereby you want to only conserve, because in IPv4, due to the limited IPv4 resources, you're forced to conserve address space, right? So in IPv6, we don't subnet to conserve address space. Rather, we subnet to optimize for routing and security. And then, like I mentioned earlier on, we don't care about the number of hosts in a certain, in our network. What we worry about is the number of subnets that we're going to get. And there'll rarely be a need to expand a /64 subnet. I think we talked of that. The only time you'll go past a /64 is for your point-to-point, which you mentioned, due to security reasons, whereby you might want to configure on interfaces. You might want to configure a /127 or 126. So unless there are any questions, I'll just check and see. I believe Stefan and Willie were. So take the time to, if you need assistance in creating your own IPv6 address plan, so use this link on the screen. And basically we're going to meet with you and help you create your own IPv6 address plan. If you need help in setting up the IPAM, if you're stuck, if you have challenges, use the link on the screen and we'll be able to help you with various IPv6 challenges that you might have. So let me look at the questions. So where can I obtain the IPAM? I'll share the link. I'll share the link before the end of the day or by tomorrow. So you'll have the link and you can set it up. And what is the maximum prefix that can be allocated to an ISP? So again, this depends on your network needs. If you do your estimates, you're going to come up with a certain prefix that you need to request from Afrinic. But when you talk of the maximum, because as RIRs, we get the blocks from IANA and then we split it up. So, but it will depend on your estimates. By default, you're going to get /32 as an ISP. And you can get /29, /24 based on your needs. If I'm an end user network, how do I push to get the IPv6, assuming my ISP has no IPv6? So if you're an end user, you can try out Hurricane Electric. So they give out free tunneling services. And if you really need IPv6, you can try Hurricane Electric, the tunnel broker service, and you can be able to get, they give you a /48. And you can have ISP in your network. You can have IPv6.
Okay, just to add on that as well, if you already having your IPv6 block from Afrinic, first step is to get, your IPv4 block. If you're already an Afrinic member, you need to first get your you need to get your IPv6 block from Afrinic. And then when you get your IPv6 block from Afrinic, you can then proceed to get that IP block to be advertised. But if you're not an Afrinic member, then you need to go to a broker. The broker would basically give you a tunnel to IPv6, and then they will give you a prefix depending on the size of the network.
Yeah. Another question is, will /60 per end site for a residential ISP be accepted by Afrinic? It greatly increases the size of prefix we will need to request. So I can say for this, we need to, first of all, based on your network hierarchy, but you can't give anything less than a /60. By less, I mean /64, because it means that the customer will not have the ability to create additional networks. So it's recommended /60 is the bare, is the minimum when you're being very stingy. But this, like I mentioned, it depends we need to do an estimate. And then based on the estimate, if you already have IPv6, based on your estimate, we can now tell the appropriate prefix length. But you can't cut corners on that. We need at least a /60 for the end customers, your customers. Another question is, Once I have established my IPv6 address plan, will Afrinic be available to check if I did it correct? Who can I contact at Afrinic to check my plan? So use the link that we have on the screen. If you feel like you need assistance in estimating and also creating your address plan and also implementing in your IPAM, just reach out to us and we're going to help. What is the best practice for the prefix length to allocate to customers with fixed IP? For now, we give /29 typically. What is the best practice for the prefix length to allocate to customers with fixed IP? So right now in IPv4, you give a /29. I think for this scenario, we'll go back to I'll recommend a /60 because that's the minimum that you still need to give out to issue to these types of customers.
And also, this is not a question that we can provide like an exact, so we will just like give a recommendation. So Bashir's recommending a /60. It all depends on how happy you want your members to be, your customers to be. Like if I'm the one, I'll basically be giving at least /56 to my customers. I won't like restrict my customers because I want them to be able to do whatever crazy stuff they have to do in their homes. There are some IPv6 folks that say basically just give /48 to everyone, residential and corporate members. So it all depends on you. Which where do you want to be? If you want to like allocate the minimum is that /60. But some people recommend do better. You can do better, right? So yeah, from /60 upwards, nothing less than that. Don't give /64 to your customers, because then if you give them a /64, they will have to do subnetting, and you don't want people to be breaking things like Slack and so on.
Thank you, Stefan. So I have another question from Patrick. When dual stacking, how do you tie your IPv6 to your IPv4? So you have 10.0.0.1/24 on an interface. How do you link that with your v6? Yes, so what you've typed, so you're saying, so you can embed information, your current addressing information in your IPv6 address. So I'll just indicate it so that everyone can see. So 20.0.1, let's say 21.0.0 or something like that. (10.0.0.1). Remember, this was from your IPv6 block. Maybe you want to map the IPv6 address for a certain server to the IPv4 address, and it will be easy for you to identify. So the IPv4 address was 10.0.0.1. So you can do this, /64, for example. But remember that there's a difference. In IPv6, this will be in hex, so it doesn't map out to the same thing. The 10.0.0.1 is in hex, so it does not equate to 10.0.0.1, which is in decimal. But you can do this. But just be aware it's not exactly the same thing.
Yep, and my question is, why would you even want to do that? So yeah, it's good you can do this, but it's not a recommended practice, because for those tools that are scanning are scanning IPv6 networks, what they will do is, if they can guess your IPv4 network, it will be easy for them to scan your IPv6 active host. So you don't want, why do you want to embed? So don't do that. Just try to do your IPv6 address plan, and you don't need to embed.
Yeah, so I usually even say that IPv6 is a chance for you to have a fresh start. Sometimes we have address plans, IPv4 address plans that we met. We don't know how they were developed, and they're very rigid. So IPv6 is will give you a chance to have a new or fresh start. Final question here is, I'm an end user network. How do I push to get IPv6? Assuming my ISP has no IPv6. I think we answered this. Yeah, we answered this earlier on.
Yeah, you did that.
Yeah.
Okay.
So thank you guys. We expect to see your links to meet you in the help desk session so that we see more address plans, more IPv6 deployments. Then I'm going to share a survey at the end of this webinar. It's very, very short. So take the time to just fill it in. Normally we use the survey to look at topics to do next time and also to improve. So until next time, thank you. Thank you, Stefan. Thank you, James.
Yep, thank you. Thank you, everybody.
That's it.